This is a demonstration of a sequencer configured on an HMI by Miles Van Tassel. The sequencer is shown in matrix format with 30 available steps, 32 inputs, and 32 outputs. The purpose of this type of sequencer is to eliminate the need for a PC and PLC programmer to do troubleshooting on a sequence. For this demonstration, passwords for the row of buttons below the matrix have already been entered. Configuration and status are available to the operator, in-house maintenance, and the PLC programmer through the HMI. Sequence status features include sequence name, input and output status, input and output description, state status shown in green, state descriptions, next state indication shown in blue, inputs not made for the next state, manual mode, configuration mode, forcing of inputs or outputs, setting and clearing of steps. Configuration features include single steps shown by 100s. These are start permits. Single branch steps, which are also shown by 100s. Multiple branch steps shown by 300s. And then they come together at the place shown by 400s. Run permit steps shown by 200s. This HMI platform is available on both Siemens and Allen Bradley. Now for demonstration of operation. I'll be turning on various inputs and you'll see the states advance. You need to remember that state 2 has a multiple branch. I can show that. States 15, 16, and 17 have run permits. Step 10 is the place where the multiple branch comes together. We return to state 0 at step 18. Let's set a bit. The state advances. Let's look at outputs for any particular output, or I'm sorry, for any particular state. Certain outputs will turn on as configured. Back to inputs. Let's go to manual mode. Let's turn on configuration. Let's select a bit. Toggle this bit. Turn configuration off. Go back to auto. Continue advancing the sequencer. Select the state or next state. Use that information. Turn a bit on. It advances. It wants to go to 3 places. Let's turn on bit 8. State will go from, let's enable forces, select the state. We advance from 2 to 9. Let's try the same thing with 6. 2 did not turn off because this is multiple branch. Force on. Let's try 3. This is the third one. This time 2 will turn off. This is an OR function being orange. Only need one of them. Turn one of those on. We advance from 2 to 3. Let's look at state 10. For state 10, we need bit 9. We have a red indication, meaning 10 will not be allowed to advance until all other steps preceding are off. Turn on a few more bits, and these states will advance. Seven will advance to 8, which will in turn advance to 9 and go to 10. The conditions for 9 are already met. Let's make the conditions for state 8 true. State 7 advance to 8, 9, and then 10. Let's do the same thing for state 4. And state 5. And that advanced to 10 faster than you could see it. State 10. Let's make state 11 advance. Let's turn off a few bits for the demonstration. Force off. State 12 is looking for 2 bits. Bit 3. Bit 11, we'll force it on. '12 is looking for another bit. 13. 14. 15. 15, 16, and 17 were run permits. They want to go back. If I remove this bit, the current state, as compared to all my previous demonstrations, which were next state. So I'm going to highlight this one. That really doesn't matter. The third bit, turn it off. It goes back. It cannot go back until the same bit is turned back on. And let's continue forward. State 16. State 17. State 18. We don't see the blue indication because the blue indication is on state 0. Let's take a quick look at that. It needs bit 8. Let's clean up a little bit, turn a few bits off. Let's turn bit 8 on by forcing. We're back to the beginning. State 0 wants to go to state 1 or to state 15. Let's select 15. Turned on. The bit, which was a run permit, was off, so it reverted back to 14. Thank you for watching. Before we quit though, I think I'll clear this current step and set bit or state 10 to show how steps can be turned off and on. Select, clear, select, set. That simple. That can only be done in manual. Back to auto. Again, thank you for watching.